Okay, this assignment you need some patience on. Okay. These brackets mean absolute value. Okay. Now, absolute value means distance from 0. So how far is it from 3 to 0? Well, 1, 2, 3. I counted 3. Absolute value is never negative. It can be a negative inside, but then when you count from -4 to 0, 1, 2, 3, 4, it doesn't matter what direction you're going for. -6, so 1, 2, 3, 4, 5, 6. Then 2 would be 2. Okay, -5. 1, 2, 3, 4, 5. You ever notice it's just a positive every time? 5, that one's 6, and that one's 6. Now, why are we doing that again? Well, because now we have to graph absolute value functions. Now, this first problem I said have patience. I'm going to make an input-output table. Okay? We're not going to be making this on the problems. It takes too long. Okay? And it's going to be really confusing when we start getting more complicated ones. So why don't you just go 3, 2, 1, 0, -1, -2, -3. Now under your y, just put what the y equals, absolute value of x, absolute value 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 x. Now you put a 3 where that x is at. Well, the absolute value of 3 is 3. Okay, so graph that point, 3, 3. So on x, 3 is here, but on y, it's here. So 3, 3. Now if I put a 2 in, that would be equal 2. So 2, 2. So 2, 2. Now if I put a 1 in, it equals 1. So 1, 1. If I put a 0 in, it equals 0. So that's just right on the line. Now when you put -1 in, how far is it from -1 to 0? It's 1, okay? It's not -1. So you go -1 on x, but then you go up to 1 on y. Okay, now you put -2 over the x. How far, what's the absolute value of -2? It's 2. So I go to -2 on x, but then I go back to -2 on y. Then -3, so that'd be 3. Now, as you can see, it makes a V shape. Absolute value functions always make a V shape, and they are continuous because you can keep going and just be 4, 5, 6, and it would make a V. Now, here's a quicker way to graph it. You write the word, this middle here, that's known as the vertex. That's the middle, it's 0, 0. So what you're going to write here is the word vertex. And you're just going to put 0, 0. Okay, that's the middle of the V. So you just make a point at 0, 0. Now you go forward 1, up 1, back 1, up 1. Do it again, and do it again. I want 7 points. So that's how to graph it quicker without the table. Now, unfortunately, they throw numbers into the absolute value. Okay. So when they throw a number, it could be inside the absolute value or outside. This particular assignment, they're on the outside. You write 2 things. You write vertex start, and that's always going to be the coordinate point 0, 0. Then you write vertex finish. Okay? Vertex start, vertex finish. Now, here's how you find your vertex finish for x. Circle the absolute value. Is there anything inside of that? No. Okay? So you will keep that at 0. Now, what do you have outside? You have a +3. So outside, you have a +3. So make this note. When you have an operation outside, you need to do the same. Do same to y. So you have a +3, you're going to +3. So now the vertex I graph is 0, 3. So X zeros here, then 1, 2, 3 on Y. Okay. There's your vertex. Now you do the forward one, up one, back one, up one, forward one, up one, back one, up one, and then do it till you have 7 points total. There you have it. And there's your function. It's the same as this is the one we did before. It's just everything's up 3 because of the plus 3. Okay, y equals the absolute value of x minus 3. So vertex start. And then the vertex finish. So the vertex start will always be 0, 0. But don't graph that. Don't graph the vertex start. Now, do you have anything operations inside of the absolute value? You don't. So the x will stay at 0. But outside the absolute value, we have a minus 3. So we put do same to the y. Okay? So you're going to go under your y and minus 3. So 0 minus 3 will take us to negative 3. So the vertex on x, 0 is in the middle, but on the y, negative 1, negative 2, negative 3. That is where we plot our vertex. So forward 1, up 1, back 1, up 1. Forward up, back up. Forward up, back up, and there's the function. So it doesn't start in the middle this time. It starts this middle that goes down 3 because of the minus 3. Okay, I don't want to be messing with, get rid of this problem, just don't do it. Okay, y equals the absolute value of x plus 5. I don't want to mess with decimals. Okay, vertex start, vertex finish. So the vertex always will start at 0, 0, but the finished product, the vertex, you circle the absolute value, there's no operation inside of it, so the x will stay at 0. Then, outside you have a plus 5. You put that you're going to do the same to y. So plus 5, that's 5. So 0, and then on y, 1, 2, 3, 4, 5. Forward 1, up 1, back 1, up 1. Okay, there you go. And that's continuous. You need arrows on both ends. Okay, 2 more on the back. Y equals the absolute value of x plus 2. So vertex start and vertex finish. So vertex start 0, 0. Okay. Don't graph that though. The finish is what you graph. Do you have anything inside your absolute value function? No. 0. Plus 2 outside. So you put that do same to y. That means go to your y and add 2. So xy, 0 on x, same as it always is, and 1, 2. Okay. So now you do the thing. Okay. Okay. Alright, y equals the absolute value of x minus 7. So vertex start. Zero, 0. Vertex finish. Okay, 0. And then you put do same to y. Okay, so minus 7, negative 7. So on the y, x is 0, so right there, and then y you just have to go down to negative 7. Yeah, I don't care if you number it, just know where you're going. So forward 1, up 1, back 1, up 1. And there we have it. So that should be a fairly straightforward assignment.